Hello everyone, welcome to this video. In our previous video, we learned to find out the solution of a quadratic equation using the factorization method, in which the middle term is in the form of bx, coefficient b of x is equal to the sum of two factors and the product of a and c. In this video, we shall see how to solve a quadratic equation by completing the square. Can you solve a quadratic equation using the factorization method? For example, here we are given a quadratic equation. Can you solve this equation using splitting the middle term method? If we try solving this equation using splitting the middle term method, we will not succeed as we cannot factorize the equation. Let us now solve the quadratic equation. X square plus 6x plus 3 equals to 0 by another method. How many terms can you see in the given equation? Absolutely right. This equation has 3 terms. Let us observe them. Talking about the first term of the equation, let it be a square, each side of which is x, whose area is the x square. Similarly, looking at the second term of the equation, suppose it is a rectangle, which has one side 6 and other side x, whose area is 6x. Can you combine these two shapes to form a new shape? Well done! If we combine the given square and rectangle, we shall get a new rectangle whose area will be equal to the sum of the area of the square and the area of the first rectangle, which means that its area would be x to the power 2 plus 6x. Now, we can divide the small rectangle, which is part of the new rectangle, into two equal rectangles in this manner. Now let's arrange the rectangular pieces in this way. On doing so, we get a new shape from this, whose total area is still equal to x square plus 6x. We can say that this shape is neither a square nor a rectangle. Can you guess what should be done to complete the shape as a square? In order to complete the shape, we need a square piece of side 3 units. Let's add a square piece of side 3 units to the figure. On doing so, we get a square, whose each side will be x plus 3 and its total area will be x plus 3 the whole square. To retain the area of the figure x square plus 6x, we will subtract the area of a square piece of side 3 units, which is 9 square units. Thus, the expression x square plus 6x can be written as x plus 3 the whole square minus 9. On comparing the given equation to the quadratic equation, x square plus 6x plus 3 equals to 0, we see that there is a shortage of plus 3 in equation 2. Hence, adding 3 to both sides of equation 2, which can be expressed as in this way, the given equation can be written as a complete square as x plus 3 the whole square minus 6 equals to 0. Can you now find the value of x by solving equation 4? Well done! If we take the square roots of both the sides of equation 4, we get x plus 3, which is equal to plus minus root 6. Can you tell me, why didn't we just consider positive root 6? That's because the square of both positive root 6 and negative root 6 is 6. Therefore, on solving the roots of the equation, x is equal to minus 3 plus square root of 6, and x is also equal to minus 3 minus square root of 6. Thus, we have found the root of the given quadratic equation by expressing it in the form x plus 3 the whole square minus 6 equal to 0. In the same way, we can solve any quadratic equation by converting it the term minus b square by 4a into a perfect square and finding the solution of a multiplied by x plus b by 2a the whole square plus c minus b square by 4a equal to 0. This method is known as completing the square method. In this video, we learned how to solve a quadratic equation by completing the square method. In the next video, we shall see examples related to it.